This lesson, our focus is switching from a geometric probability model to a binomial probability model. So the first thing we're going to talk about is what is a binomial probability model and what's the difference between that and the one we talked about last class. A binomial counts the number of successes in a fixed number of trials. That's one of the big differences. You have a set number of trials that you are repeating your experiment. And all we're focused on is how many total successes did you have in that set number. Geometric, there was no set number of trials. You stopped the minute you got your first success. There was only allowed to be one success. Now there can be multiple. For a binomial probability model, you need two parameters. First, you need n. N represents the number of trials that you are doing. And then p is the same p we've learned before, and that's the probability of a success. And our notation for a binomial model is BINOM for binomial, binom, and then the number of trials always comes first, so that's going to be a whole number like 1, 2, 3, 4, and then p always comes second, and because p is a probability, it's a decimal or a fraction between 0 and 1. So let me give you an example of what these kinds of problems look like. You're focused on finding the probability of exactly 2 successes in 4 trials. So you have 4 total trials and 2 successes. Well, there's different times that those successes could happen. You could have a success, and then 2 failures. You could have a success, a failure, a success, then a failure. You could have a success, a failure, and a success. You could have a failure and a success and a success and a failure. You could have a failure, a success, a failure, and a success. Or you could have the first 2 failures and the second 2 successes. Now, I don't expect you to know all of these possibilities, but for 4 trials and 2 successes, there's technically 6 different options that we have possible. So with these specific models, we have to have a way of quickly and easily calculating how many possibilities there are, because there were 6 possibilities here. Now imagine if we changed it to 20 trials and say 7 successes. That could get a lot harder to do a list like we just did. So we need to have an easy way of figuring out how many different combinations there are. So that introduces the concept of combination. A combination calculates how many different ways you can rearrange your successes and failures. There are 2 different notations that you will see. The first one is this guy right here. N is your number of trials, and K is your number of successes. And C, we use the word choose there. So you have the number of trials, and you are choosing a set number of them to be successes. This is also a way that you will see it written. Those are 2 parentheses, and it kind of looks like a fraction, but without the fraction bar. It's just the number of trials on top and the number of successes on the bottom. Well, there is a formula to calculate this. I'm going to show you the formula, but luckily we have our graphing calculators, which allow us to do this without the need for this formula. So the way the formula works, this right here is N is the number of trials, and there's this exclamation point. Well, the exclamation point is what we call a factorial. K down here is the number of successes. And if we take the number of trials minus the number of successes, this just represents the number of failures. So this factorial thing, let's say for instance the number is 4 factorial. What that factorial means is you take your highest, you take the number you're given, 4, and you multiply it by every number below it down to the number 1. So 4 factorial would be 4 times 3 times 2 times 1, or 24. So this little formula here, as much as it is different, we've never seen it before, I'm not asking you to memorize it. I'm not even asking you to know how to use it. I'm going to show you how to use the calculator, and we're going to leave it at that. So let's take a look at a few problems just to practice, and I'm going to go through the calc steps. So all 3 of these are combinations. The top number again, if you remember, the top number is the number of trials. The bottom number is the number of successes. So the way we type this in the calculator, you will always type the top number in first. So this would be 4. Now, in your graphing calculator, you're going to hit the math button. You're going to arrow over to, and I'll jot down these steps, you're going to go to math, and you're going to go to the PRB menu, that stands for probability, and you should see an option that looks like NCK. Or I think in your calculator it's NCR. That's, letters are interchangeable, that's the option that we're going to be using. And so you would press the NCR button, and then it asks you to put in the second number, and our second number is 2. And if you type that in your calculator, and yes, you might have to practice when you get back to school, you will get the number 6. So same thing with the next one. You would type in the top number first. By the way, the top number will always be the bigger one also. Then you would hit the math button. You go over to PRB, go down to option for the NCR, and then you would put in the number 4. And if you did it correctly, your calculator should spit out 35. So we quickly, the first one was the one that we wrote out. 4 trials, 2 successes. 6 answers, that's what we got in the previous slide. This one, all I did was increase to 7 trials, and I increased to 4 successes, and it quickly jumped to 35. Not something you're going to want to hand calculate. So this last one, type in your first number, that's your 10. Again, math, PRB, NCR, and then put in the 6, and you end up with 210. Again, we didn't increase those numbers very much, but that's how quickly it increased. So you're going to see this combination notation in our formulas today. And again, your calculator is going to do all of that work for you. No need to worry. So let's take a look at the important formulas for today. So just like last class, we have a probability formula, an expected value formula, and a standard deviation formula. So first thing is your probability formula. We're trying to find the probability of exactly K successes in N trials. So this first part here that we discussed, the combination, this takes into account all of your different ways of rearranging. Okay, so these are your rearranging options. This here is your success, and K is simply the number of successes. Q is your failure probability, and this N minus K, it's just your number of failures. So some things to keep that you need to know, P and Q have to add up to 100% or 1, and the number of successes and the number of failures has to add up to the number of trials. So if you have 10 trials, 6 of them are successes, that automatically means 4 of them are failures. If you have 5 trials, 2 of them are successes, that automatically means 3 of them are failures. And so this is all broken down right here. N is your number of trials, K is your number of successes, P is the probability of a success, and Q is the probability of a failure. This formula for expected value, extremely easy. Okay, if you remember, this is just a symbol for the expected value of X. We simply take N, the number of trials, times P, the probability of a success. The standard deviation is just the square root of N, number of trials, times P, success probability, times Q, failure probability. So both of those are very easy formulas. Again, this guy, standard deviation, the other one, expected value. Now, for today's lesson, we're going to spend most of it focused on using the top formula to get you comfortable with reading the problems, knowing what it's asking, and filling it in. The next lesson, we'll go ahead and touch on the other 2 formulas. So you don't even need to worry about expected value or standard deviation today. So let's take a look at our first example. Pastini is a global company specializing in communications security. The company monitors over 1 billion internet messages per day and recently reported that 91% of emails are spam. Suppose your email is typical and you also receive 91% spam. If you have 8 new email, find the probability that. Now before we answer the question, we're going to write down everything we know. We have a total of 8 email. That is your number of trials, so that's your N. Your N is 8. Now, spam is one of your percentages, and that's 0.91, which means non-spam is what's left over. Well, 100% minus 91% is 9%, or 0.09. So there's all of our important info that we're going to use to plug into our formula. Now we want to look at the probability that you have exactly 3 spam. So if we have 3 spam and we have a total of 8 emails, that means that 5 of them are non-spam. So looking at your formula, the first thing we do is that combination thing. Calculator does it for you. We're just going to write it in the formula. The top number is the number of trials, that's 8. The bottom number is the number of successes. Well, in this case, we're going to consider spam the success. So we're going to put the 3 there. Then we look at our percentages. Well, the probability of spam is 0.91, and there's 3 of those, so we're going to raise it to the 3rd power, times non-spam is 0.09, and there's 5 of those, so we're going to raise that to the 5th power. Now, I don't want you to use your calculator to do each little thing individually. You're going to type it all in at one time. So if you pick up your calculator, to do this first part, remember we type in the 8 first, we go to math, over to PRB, and we need the NCR option. After that, you put in the number 3. Now, we do need to put a multiplication dot here, so times 0.91 exponent 3. Make sure you get out of the exponent, so use your right arrow, then times 0.09 exponent 5. And if you do that correctly, you should get a decimal of 0.0002. And if you remember from last class, we're going to consistently use 4 decimals. So let's look at part B. All I'm changing now is instead of 3 spam, I now have 6 spam. So if we have 6 spam and we have a total of 8 emails, that means that 2 are your non-spam. So we're simply changing basically the exponents. You still have in your combination 8 email, but now we have 6 of them that are spam. times the spam percentage was 0.91. It's now increasing to 6 times non-spam percentage is 0.09, and that decreased down to 2. So if you look at our two problems, the two exponents changed, but they still add up to 8, and the bottom number in the parentheses changed to match the exponent for the spam. Pick up your calculator, go through those exact same steps of plugging it in. And the plugging in part, the quicker you get at it, the easier it'll be. If you did it correctly, you should get 0.1288. If you have a calculator at home, make sure that you're practicing this, or I know a lot of you downloaded it to your phone or maybe your computer at home. Don't just write down my answers. Make sure that you're practicing this because they are a lot of buttons to push and you want to make sure you're getting the right answers. All right, so let's look at a new example. All we're going to do is change up some of the numbers. You are taking a 10-question multiple choice test, and each question has 4 answer choices. Unfortunately, you didn't study for the test, so you are completely guessing on each question. Find the probability that. So let's write down what we know. How many questions total were on the test? There's 10. So that means that the number of trials is 10. Now, the probability that you get it right, you got 4 options. The problem is you didn't study, so you are completely guessing. Well, the chances of getting it right, since there's 4 answers and there's only one right answer, is 1 out of 4 or 0.25, which means the chances of getting it wrong are 3 out of 4 or 0.75. So now that we've broken down all of our important info, let's take a look at our question. So what's the probability that you get exactly 6 questions correct or right? So if you got 6 of them right, and there's 10 questions, that means you got 4 of them wrong. So let's start with our combination. There are 10 questions that we are answering, and we need 6 of them to be correct. The probability for being correct, I'm going to put times here, is 0.25. There's a total of 6 of those. Times the probability you get it wrong is 0.75. And there are 4 wrong ones. And so take a second, type in your calculator, pause the video so that you have a chance to type it in, and let's see if you get the right answer. I ended up with 0.0162. So hopefully you got that answer. Let's look at the next one. You get only 2 questions wrong. So 2 wrong out of 10 means that you got 8 correct. So we're just changing our exponents and the number at the bottom of the parentheses. 10 questions total. Now we have 8 of them correct, times only a 25% chance of getting it correct, but there's 8 of those, times 75% chance of getting it correct. I'm sorry, wrong. And there's 2 wrong answers. Type that in the calculator. Comes out to be a pretty small decimal. The chances of you getting 8 correct guessing is 0.0004. Pretty small number. So hopefully you're looking at this thinking, okay, these formulas aren't too bad. So now we're going to do a little bit of trickier work here. We're sticking with the same question, the same N, the same right, and the same wrong. So now, what's the probability that you get at least 3 questions correct? Well, first of all, let's break down what that means. When you hear the phrase at least, and then they give you a number, what that translates to us is that number or more. So when we hear the phrase at least 3 correct, that means you get 3 or more correct. Well, that's a bunch of options. That's 3 correct, 4 correct, 5 correct, 6 correct, 7 correct, 8 correct, 9 correct, or 10 correct. That's a lot of options. Now, you can do all of those cases, 3, 4, 5, 6, 7, 8, 9, and 10, which by the way, that's 8 of them. Or we can think about the complement. We've learned this before. What are the ones that we don't want? Well, if we want 3 and above, the only thing we don't want is 2 correct, 1 correct, or 0 correct. Now that's only 3 options. To me, that's a lot easier to find than 8. And so that's what I'm going to do is I'm going to use the complement. So I'm going to focus on 0 correct, I'm going to focus on 1 correct, and I'm going to focus on 2 correct. So if you have 0 correct, that means that you have 10 wrong. If you have 1 correct, that means you have 9 wrong. And if you have 2 correct, that means that you have 8 wrong. And so for each one of these, the setup is just like part A and B. All we're doing is changing the exponents. So the first part, 10 total questions, 0 correct, times 0.25 to the power of 0 times 0.75 to the power of 10. So that's the case for 0 correct. Then we have 1 correct. So because this is options, this is an or between all of these, which means I'm going to put a plus sign here. Now the only thing that's changing is the zeros and the 10. The zeros are increasing to 1 correct. So there and here. And the 10 is going down to a 9 correct. So that's the case for 1. Now we got our last case, which is 2. So the 1s are changing to 2s. The 9 is changing to an 8. So 10 over 2. I don't know why I keep writing on my screen with my hand. 10 over 2 times 0.25 to the power of 2 times 0.75 to the power of 8. Now, I want you to type this in all at one time. And all you're going to do is type in each one of them, just like we did on parts A and B. And you're just going to put a plus sign in between each case. So if you need to, pause the video. I want you to try typing it in. And then when you're done, unpause it. We'll see if you got the right answer. So I ended up with 0.5256. Hopefully you did as well. The thing is, that's not the answer we want. That was our complement. So if you remember, anytime we use the complement, we take 1 minus that answer to get the answer that we wanted, which in this case is 0.4744. Okay, so let's look at the next one. Again, it's got wording. So we've learned that, and I'll kind of separate that here. We learned that at least when they give you a number means that number or more. Our new phrase on this one is you get no more than 5. Again, you need to know what that means. No more than a number. This translates into the number or, let me make that look like an or, not an and. Looks like the number or less. So there's your other little phrase that you will hear pop up a bunch. So no more than 5 means 5 or less. So 5, 4, 3, 2, 1, and 0. So that's 6 cases. quite a bit of work. We're going to write them all out. But again, your calculator is going to do it all at one time. So we got 5 correct, 4 correct, 3 correct, 2 correct, 1 correct, and hopefully it'll fit in here, 0 correct. Remember, all we're doing on each one of these, keeping the exact same setup, we're changing the exponents and the number in the bottom of the parentheses. The correct is always the first numbers, the one in the bottom of the parentheses and the first exponent. So 10 over 5, 0.25 to the power of 5, because those first ones match, times 0.75. And if you have 5 correct out of 10 questions, you also have 5 wrong, because they have to add up to 10. And so each time, all we're doing is we're decreasing the number of correct and increasing the number wrong. Plus, because these are cases, so the first 5 changes to a 4. We're going down with the number correct. So the 0.25 goes down to 4. And the 0.75 goes up. 4 plus 6 is 10. Plus, the 4's change to 3's, the 6 changes to 7. 10 over 3, 0.25 to the power of 3, times 0.75 to the power of 7, because 3 plus 7 is 10. Now the 3's change to 2, the 7 goes up to 8. 10, choose 2, 0.25 to the power of 2, times 0.75 to the power of 8. The 2's go down to 1's. The 8 goes up to 9. 10, choose 1. 0.25 to the power of 1 times 0.75 to the power of 9. And I think I'm going to run out of space, so I'm going to come down here at the bottom. For 0 correct, the 1 changes to 0, the 9 changes to a 10. So 10 over 0, 0.25 to the power of 0 times 0.75 to the power of 10. So pick up your calculators, pause the video, take your time, be very careful. This is why it's important on the test. Write out all these details, because if you write it all out and you do make a mistake in the calculator, all you're going to lose is 1 point if I see everything you wrote out. But if you don't show me any of that, I can't give you partial credit. The answer that I got from the calculator was 0.9803. Hopefully you got the same answer. So we have one more set of examples left that we are going to look at. So a bowler has a 75% chance of getting a strike every time he goes up to bowl. If a game consists of 10 frames, find the probability that. So what all do we know? We know the number of frames is 10, so that's n. He gets a strike 75% of the time, so that's 0.75. And we're just going to call everything else a miss. He misses the rest of the time. Well, that's 25%. So let's look at the first problem. This is a straightforward one. The bowler gets a strike in exactly 6 frames. Anytime you hear the word exactly, it's one case, that number. So 6 frames he gets a strike, which means 4 frames he misses. So let's set it up. How many frames total? 10. How many strikes? 6. What's the probability of a strike? 0.75. We have 6 of those. Times, what's the probability he misses? 0.25. And how many times does that happen? 4. Calculator, if you type it in, you end up with 0.1460. Okay, so let's step it up one. Now, the probability that your bowler gets a strike in 7 or 8 frames. So, not a whole bunch of cases, just 2, in 7 frames or 8 frames. So, again, your setup is staying the same. The only thing that's changing is the 6s and the 4. So, the or means we're going to add our 2 cases together. First case, 10 frames. How many strikes? 7. 0.75, there's 7 of those, times 0.25, there's only 3. Other case, the 7s change to an 8, and the number of misses goes from 3 down to 2. So 10 with 8 strikes, 0.75 to the power of 8, and 0.25, as we said, to the power of 2, because 8 plus 2 is 10. Type both cases in all at one time. You'll get 0.5318. Let's look at part C. What's the probability that the bowler gets a strike in at least 1 frame? There's that phrase again. At least 1 means 1 or more. So it could mean 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10. That's a lot of cases. That's 10 different options. Well, again, if you have too many options, think about the ones that we don't want. Well, the only case that we don't want is 0. So that's the case we're going to find. We're going to find the case that he gets 0 strikes, which means he has 10 misses. So let's do that. So 10 frames, 0 strikes. Probability of a strike is 0.75. We got 0 of those. Probability of a miss is 0.25, but we have 10 of those. Okay, so your calculator, you type all of that in. You're going to get a very, very small decimal, and you're going to probably get scientific notation. Your calculator probably spit out the following kind of strange looking answer, like 9.5 with the E and with a negative 7 there. We've seen scientific notation before. All that means is you move the decimal 7 spots to the left. So that would give us a really tiny number. It would give us 0.60 and then 95, which is very, very tiny, but it's scientific notation. I don't want you to freak out when you see it in the calculator. I want you to know what it means. But if you remember, this problem that we were doing here, this was a complement. So we needed to take 1 minus that number. And so if you do 1 minus that point with the 6 zeros and then 95, you're going to get a whole bunch of 9s. 1, 2, 3, 4, and it keeps going. You don't need to go any higher than that. 4 decimals is fine, but do not round it to 1 because it's not actually 1. All right, so we got 3 more examples, all relating to the bowling problem. This time the bowler gets a strike in at most 4 frames. So if you remember, at most means 4 or less. So we have to do the case of 4 strikes, 3 strikes, 2, 1, and the case of 0. And we're going to add them all up. So we have 10 with 4 strikes. 0.75 is the probability of a strike to the power of 4 times 0.25. 10, take away 4, leaves us with 6 misses. Plus, all that's changing, the 4s are changing to a 3. The 6 is changing to a 7. So 10 with 3 strikes, 0.75 to the power of 3, 0.25 to the power of 7. Plus, now we got 2. Let me move that 2 because it's going to get in the way. We got the case of 2. So now the 3 changes to a 2. The 7 changes to an 8. So 10, 2 strikes, 0.75 to the power of 2 times 0.25 to the power of 8. Okay, we got 2 more cases. We got the case of 1 and we got the case of 0. So the 2 changes to a 1, the 8 changes to a 9. 10 with a 1, 0.75 to the power of 1 times 0.25 to the power of 9. And finally, the 1 changes to a 0, the 9 changes to a 10. 0.75 to the 0, 0.25 to the 10. So we got a whole bunch of cases there. You're going to type them all in the calculator one at a time. Remember, don't accidentally type in my 3 and my 4 that I wrote there. So type in each one at a time. And what do you end up with? Well, I ended up with 0.0197. Hopefully you got the same answer. So let's look at the next one. The bowler does not get a strike in every frame. So he can get a whole bunch of strikes. He just can't get a strike in every frame. Well, if he can get a whole bunch of strikes and there's only one option he can't get, again, we're going to use the complement. So we are actually going to find the probability he does get a strike in every frame. So that means he gets 10 strikes. So let's look at that. 10 frames, 10 strikes. 0.75 to the power of 10. If he gets all strikes, that means misses. There's 0 of them. So remember, this is the case that we don't want. So one case only, easy to figure out. My calculator spit out 0.0563. But this is a complement, which means we need to take 1 minus that answer, which I end up with 0.9437. All right, let's look at our very last question for this lesson. What's the probability the bowler does not get a strike in no more than 2 frames? Okay, so you're looking at that and you're like, okay, that's really wordy. He does not get a strike in no more than 2 frames. So no strike in no more than 2 frames. So let's focus on this part first. No more than 2 means 2 or less. So 2, 1, and 0. But the focus is not a strike. The focus here is not a strike. So this is not 2 strikes, this is 2 misses. And this is 1 miss. And this is 0 misses. So it's kind of a backwards thinking. So we just got to figure out, well, how many does he make? Well, 2 misses means 8 strikes. 1 miss means 9 strikes. 0 misses means 10 strikes. So that's all we needed, was just to figure out the wording. Now we can fill in the numbers. So 10 frames, 8 strikes. 0.75 to the power of 8 times 0.25 to the power of 2 plus 10 frames, 9 strikes, 0.75 to the power of 9 times 0.25 to the power of 1 plus 10 over 10, 0.75 to the power of 10 times 0.25 to the power of 0. So it wasn't that it was tricky. It was, okay, let's start with no more than 2, which is 2 or less. But this time, no strike means that those were misses. So if you type all of that in the calculator, and since I'm out of room, I'm going to put it over here. I ended up with 0.5256. And that's the end of the lesson.